Hello and welcome to our lesson today, which is on graphical solutions of cubic equations. In our previous lesson on graphical methods, we simply learned about filling tables from given functions and drawing graphs. In this lesson, we will still fill tables and draw graphs but of a cubic equation. But what is a cubic equation or expression? When you look at this expression, ax cubed plus bx squared plus cx plus d, the highest power of the variable x is 3, and a, b, c, and d are constants where a is not equal to 0. Such an expression as this is called a cubic expression. Other examples of cubic expressions are 4x cubed plus 2x squared plus 5x plus 1. In this one, a is 4, which is greater than 0, and x is raised to power 3. In another expression, x cubed minus 7x squared plus 6, a is 1 and x is raised to power 3. These expressions therefore qualify to be cubic expressions. Now, to come up with the values of y given a function of a cubic expression, we will fill a table in the same manner we did in the previous lesson. But in this case, we will have more rows in the table. Let's consider this function. Y is equal to 2x cubed minus 3x squared minus 3x plus 2. We find the corresponding values of x and y in a table as follows. You will have the column of x, of 2x cubed, of negative 3x squared, of negative 3x, of positive 2, and finally of y is equal to 2x cubed minus 3x squared minus 3x plus 2. In our case here, we are not given the values of x, but we create our own. We can use x ranging from negative 3 to positive 4. Note that when you're choosing your own values of x, always consider values that are not too big in order to come up with a manageable graph. For a function y is equal to 2x cubed minus 3x squared minus 3x plus 2 and x ranging from negative 3 to positive 4, our filled table will look like this. In plotting these points, since the highest value of x is 4 and that of y is 70, you can have a scale of 1 centimeter representing 1 unit for the x-axis and 1 centimeter representing 20 units for the y-axis. The graph is going to look like this. After having your graph, you can be told to use it to solve the equation 2x cubed minus 3x squared minus 3x plus 2 is equal to 0. How do we use a graph to solve such an equation? The solution is given by reading off the values of x where the curve cuts the line y is equal to 0. This line y is equal to 0 means that the curve cuts the graph at some points in the x-axis with y being 0. In our graph above, the values of x when y is equal to 0 are the first point where the curve cuts the x-axis is at negative 1, the second is at a half, and finally at 2. At these points, y is equal to 0 as shown in the graph. Let's look at another example. Draw the graph of y is equal to 2x cubed plus x squared minus 5x plus 2 for the interval of x ranging from negative 3 to positive 3. Then, use your graph to solve the equation 2x cubed plus x squared minus 5x plus 2 is equal to 0. And also, by drawing a suitable straight line using the same axis, solve the equation 2x cubed plus x squared minus 5x plus 2 is equal to 6x plus 12. In solving this, we are told to use the values of x from -3 to +3. So, to find the corresponding values of x and y for the function y is equal to 2x cubed plus x squared minus 5x plus 2, we substitute these values of x in the function y is equal to 2x cubed plus x squared minus 5x plus 2. You can have these values in a table as shown. Similarly, use the same values of x, that is from -3 to +3, and find the corresponding values of y for the function y is equal to 6x plus 12. Now, plotting these points, we will obtain the graph below. For the function y is equal to 6x plus 12, it is a straight line and intersects the curve as shown in the diagram. In solving part A, that is in using the graph to solve the equation 2x cubed plus x squared minus 5x plus 2, we will read off the points where the curve cuts the x-axis with y being 0. From the graph, the first point where the curve cuts the x-axis is at x is equal to -2, then at x is equal to 1/2, and finally at x is equal to 1. These are the solutions of the equation 2x cubed plus x squared minus 5x plus 2. In solving part B, which is solving the equation 2x cubed plus x squared minus 5x plus 2 is equal to 6x plus 12, we read off the points where the straight line intersects the curve. These points are x is equal to -2, x is equal to -1, and x is equal to 2.5. These are the solutions of the equation 2x cubed plus x squared minus 5x plus 2 is equal to 6x plus 12. Basically, we have used tables of values and drawn graphs of cubic equations, as well as interpreted information from these graphs. In our next lesson, we will use graphs to determine the average rate of change.